So I want you to put yourself in a really specific, honestly pretty uncomfortable scenario that could very well be playing out in your company right now.
Yeah, the kind of scenario that gives engineering leaders literal nightmares.
Exactly. I mean, just picture the enterprise environment you operate in on a daily basis. You've got multiple AI initiatives in production,
But
right?
they're live, they're out there.
Yeah, they are interacting with your customers. Maybe they're routing internal systems or, optimizing your supply chain. And you've done all the standard groundwork.
You've got the compliance stacks.
Oh, yeah, beautifully formatted with all the corporate branding. You've rolled out those mandatory AI training programs for the whole staff.
And you've got those sleek, dark mode dashboards up on a monitor somewhere.
Yep, in the engineering bay with the glowing green lights showing like 99.9% uptime. So you feel secure, you feel innovative.
But then, reality hits.
Great. Suddenly the general counsel walks into the room. Or maybe it's just a really direct message in the executive Slack channel from your chief risk officer.
Those are always the scariest messages.
Absolutely. And they ask one simple, just terrifyingly direct question. They say, can we reproduce exactly why this specific AI system made this exact decision to deny this particular customer's application yesterday at 2:14 p.m.?
And that is the exact moment the music just abruptly stops. The whole illusion of control completely shatters.
You can almost hear that agonizing, heavy silence. People are just looking around the room waiting for someone else to take the bullet.
The product manager is looking at the data science lead.
And the data science lead looks at the VP of engineering. And then comes that inevitable, frantic, ad hoc scramble.
The panic JIRA tickets getting spun up out of nowhere.
Oh, yeah. The data engineers writing custom database queries in a cold sweat. And then you get that creeping, sickening realization that the system logging the customer's inputs doesn't actually talk to the system logging the language model's outputs.
It's basically an absolute forensic nightmare.
Totally. And that terrifying moment of realization, that is the core premise of our deep dive today.
It really is the elephant in the room for so many companies.
It is. We are looking at a really fascinating stack of sources today, a mix of architectural blueprints, regulatory analyses, and some raw field notes from operators.
And they are making a really bold, urgent claim here.
Very bold. They're saying that the biggest AI risk you face right now as a builder or an enterprise leader is not model hallucination.
Right. It's not the inherent bias in the training weights either.
No, it is the missing black box.
Because, we spend an inordinate amount of time and, frankly, millions of dollars worrying about whether a generative model is going to output something factually incorrect.
Yeah, or if it's going to generate biased texts, which, are valid concerns.
They are valid, totally necessary concerns. But from a systemic enterprise risk perspective, the hallucination is literally just a symptom.
Right. The true existential threat is the inability to explain the mechanism of that symptom.
Exactly.
Yeah.
Because if you cannot trace the lineage of a specific output backward, like through the exact prompt, the specific model version, the user input, and the governing corporate policy active at that exact millisecond, you don't actually have a governed system.
You have a liability engine. You are completely missing a unified evidence stack.
So why does this matter to you, the listener, right this second?
Because today, we are going to arm you. We're going to walk through a highly practical, step-by-step, 48-hour drill to audit your current AI decision logs.
No hypotheticals here. This is a raw operational stress test.
Right. We're going to show you how to take the painful findings of that drill and map them directly to the looming EU AI Act compliance obligations.
Which is crucial for getting leadership on board.
Exactly. We'll outline how to translate all that into a really concise, hard-hitting board-level memo for your CFO, one that clearly summarizes your massive capital exposure.
And finally, we're going to reveal how to flip this entire regulatory nightmare into a distinct, revenue-driving sales asset during your most critical client negotiations.
Because this is fundamentally about competitive asymmetry, isn't it?
It absolutely is.
Yeah.
The strategies we're unpacking today aren't just like defensive maneuvers to avoid massive fines.
They're offensive strategies.
Yeah, this is for the operator who wants to be the one person in the executive suite who knows with mathematical certainty that the floor is going to hold when the pressure mounts.
Because make no mistake, the pressure is coming.
It is coming very fast.
So let's start by looking at the philosophy behind how we're actually building AI right now and why it is so structurally flawed.
Yeah, before we can audit the missing black box,
Okay.
we really need to understand what a real control point actually looks like.
Right. And our sources brought up this incredible, visceral story from an engineer whose career sort of bridges the gap between physical hardware and digital intelligence.
It's such a grounding anecdote.
It really is. They describe their lived experience on a factory floor watching workers handle actual live grenades.
Which is just wild to think about. That specific anecdote really grounds this whole abstract discussion into something highly tangible.
Yeah, this engineer observed factory workers handling volatile explosive material day in and day out.
And they noted that the workers were operating as if they were, like, perpetually holding their breath.
Wow. Yeah, every single micro movement was tense, calculated, and just exhausting.
Because these stakes were immediate, they were physical, and they were absolute. A mistake meant catastrophic harm.
And the crucial takeaway the engineer noted here was really interesting. When they eventually designed and deployed a robotic system to handle those grenades on behalf of the workers.
The motivation was not innovation.
Right. It wasn't to get a flashy headline in a tech blog or, to boost the stock price with some big AI announcement.
It was driven entirely by fear
Yeah.
and the absolute necessity of safety.
The robotic system was built so those workers could go home at the end of their shift uninjured and say, I am safe tonight.
That detail really gives you pause.
It gave me pause when I read it, too, because it forces a complete reframing of the purpose of advanced technology.
Especially in the current hype cycle, right? We constantly talk about AI replacing humans or 10xing human output.
But the roots of real critical engineering are about restoring the human. It's about protecting the human operator from systemic, catastrophic risk.
So how does that physical, life-or-death hardware engineering translate to the software we're building today?
It translates directly to the concept of the control point and this idea of an infrastructure of accountability.
Think about the physical world of engineering. If you're building a commercial airliner or an industrial robotic arm,
Or even advanced driver assistance systems for cars.
right, safety is the absolute foundational layer. You do not just build a massive jet engine, bolt it to a wing, and hope it works.
No, you surround that engine with a massive redundant system of telemetry, thermal sensors, and these heavily armored black boxes to monitor literally every millimeter of its operation.
But look at the digital intelligence space right now. With generative AI and large language models, we are treating these statistical systems like magic engines.
We really are. We're pouring billions of dollars of capital into training, compute, and deployment.
And then we just hook the magic engine up to the enterprise workflow, hit the gas, and cross our fingers.
I'm thinking of an analogy here. It's like we've built a cutting-edge Formula One car, right? An absolute marvel of engineering, incredibly fast, pushing the boundaries of physics.
But we were in such a rush to get it on the track that we forgot to install the telemetry data transmitters.
Yes. And we didn't install the dashboard gauges either.
Right.
So we know it's going incredibly fast around the track. The crowd is cheering. The investors are happy. But if it suddenly veers into the concrete wall at 200 miles an hour and shatters into 1,000 pieces...
We have absolutely zero data to tell us what happened.
Exactly. We don't know if the brake line burst, if the steering column snapped, if the software miscalculated the downforce, or if the driver just sneezed and jerked the wheel.
We are literally just staring at a wrecked car with no explanation, trying to guess what went wrong.
And in the enterprise AI landscape today, we are racing massive fleets of these telemetry-less cars.
The gap between physical hardware engineering and software engineering is largely cultural.
How so?
Well, in physical engineering, it is illegal and frankly unthinkable to deploy a system without a flight data recorder.
Right.
But in software, we have spent the last 2 decades being rewarded for the whole move fast and break things ethos.
Which is highly profitable when you're building, say, a photo sharing app.
Exactly. But it is disastrous when the thing you are breaking is a human being's access to credit.
Or their civil rights in a hiring process.
For a multinational company's regulatory standing. The sophistication of your LLM's prompt engineering is utterly useless if you do not have an accountable product infrastructure sitting behind it to legally prove why the prompt generated a specific output that harmed a consumer.
Practical execution and traceability matter infinitely more than empty architectural vision,
Yeah.
which naturally leads to a very uncomfortable realization. If the evidence stack is so obviously the control point, if it's so apparent that we need a digital flight data recorder for our AI systems, Why are we flying blind?
Why doesn't every Fortune 500 company have this installed as standard operating procedure?
Right. When you look at the sources, they make a very compelling and honestly somewhat cynical argument here.
The lack of visibility isn't just an accident of early-stage technology.
No, it is a sustained ecosystem.
Right.
So let's look at who actually benefits from this obscurity, because obscurity is highly profitable for certain players.
We really have to examine the market incentives to understand why AI remains so opaque.
The sources identify two massive culprits who benefit immensely from the status quo.
The mega-cap model, vendors and cloud providers, and the systems integrators.
Yeah.
The massive consulting firms.
Okay, let's unpack the cloud providers first. Because
Yeah.
if I'm a CTO listening to this, I might be thinking, wait, my cloud provider does sell governance.
Right. They see the dashboards.
Yeah, when I log into their AI studio, I see an entire tab dedicated to safety, governance, and compliance. There are charts, there are graphs.
Oh, they absolutely do sell governance features. But you have to critically examine the underlying architecture of those dashboards.
They're fundamentally closed loops, right?
Yes, they are designed, quite intentionally, to keep the enterprise locked into their proprietary logs, their proprietary storage formats, and their specific ecosystem.
So if you're using cloud provider A's foundation model, their governance dashboard works relatively well for tracing activity within cloud provider A's walls.
Gives you a comforting illusion of control.
But the reality is almost no sophisticated enterprise operates in a single model vacuum.
Exactly. You have a highly fragmented multi-model environment.
Right, like
Yeah.
you might be using an open weights model hosted internally for sensitive document summarization.
And then you might be calling a proprietary API from a major vendor for complex reasoning tasks.
And maybe you have a legacy machine learning model handling basic routing somewhere else.
And cloud provider A's shiny governance dashboard is completely blind to everything outside its own walls.
Wow.
It will not give you a unified, normalized evidence stack across all of those disparate systems. It literally serves as a lock-in mechanism masquerading as compliance.
So the vendors are using fragmentation to keep you tethered. What about the systems integrators? The global consulting firms that you call when things go wrong.
Oh, the SIs generate massive, unparalleled revenue by billing for manual remediation.
Think about the business model there.
Right. When a regulator sends an inquiry or an internal audit flags a massive discrepancy in AI decisions, the company panics.
And who do they call? They call their SI partner.
Exactly. The SI deploys a team of highly billed analysts, data scientists, and risk consultants.
And what do those consultants actually do?
Well, they manually dig through raw application logs. They interview the engineers who built the system. They try to retroactively piece together a narrative explanation of what the AI did.
They basically bill thousands of hours over 6 months to produce a massive static PDF compliance report.
Yes. But here is the critical failure. They rarely, if ever, fix the structural absence of a cross-system evidence layer.
Wait, I want to make sure I'm grasping the magnitude of this. When a company hires an SI to do an AI audit or buys a compliance dashboard from a vendor, they aren't actually buying a cure.
No, they are buying an incredibly expensive temporary patch for a symptom.
They're paying for a bandage by the hour when they need structural surgery to fix the bone.
That is exactly it. The phrase the sources use, which is just brilliant, is fragmentation is a business model.
That is such a chilling phrase.
It is. These external players have a vested financial interest in keeping the truth fragmented across different systems.
Because if your data lineage was instantly queryable in a unified, normalized evidence database,
If you could just type in a customer ID and see the exact millisecond by millisecond flow of their data through the AI models and the corporate policy engine.
then the SIs wouldn't be able to bill for a 6-month manual audit.
Exactly.
Yeah.
And the cloud vendors wouldn't be able to use proprietary logging to prevent you from migrating to a cheaper model.
That is a staggering conflict of interest. It really begs the question, when a critical AI incident occurs, and it definitely will, do you really want to rely on the vendor grading their own homework?
Or do you want to rely on the consultants who bill you to clean up the leaks to be the sole arbiters of why the engine failed?
You don't. You need an independent structural layer of truth.
You need an evidence stack that you own, that you control, and that sits entirely outside the vested interests of the vendors.
But I mean, if companies are just coasting along right now, happily paying SIs and trusting vendor dashboards, what's the catalyst that's going to force them to wake up?
Why the sudden desperate urgency to build this independent truth layer now?
That brings us to the most sobering part of the sources, the 2026 cliff.
Yeah, we are moving from a world where AI ethics was basically a philosophical debate at academic conferences
Hmm.
into a world of brutal balance sheet
The
reality.
theoretical discussions are completely over.
The regulatory hammer has already been forged. It is currently in the air, and we know exactly when it's going to strike.
Mid-2026 is the date our sources highlight repeatedly.
Yes.
So what specifically happens in mid-2026?
That is when we see the massive enforcement spike of the European Union's AI Act.
Specifically, the strict obligations surrounding what they classify as high-risk AI systems and prohibited practices.
And it is crucial to understand this is not just a European issue. The Brussels effect guarantees global impact.
Plus, we are simultaneously seeing the ramp up of severe local data protection regimes, like the Digital Personal Data Protection Act in India.
Alongside various sectoral norms across the US and Asia, the net is definitely tightening globally.
We really need to talk about the stakes here, because they are just staggering. We aren't talking about a slap on the wrist or a minor cost of doing business.
We are talking about existential financial penalties.
The EU AI Act introduces fines up to 35 million euros, or 7% of a company's global annual turnover, whichever is higher.
7% of global turnover. Just pause and really think about that.
For a multinational Fortune 500 company, that is not millions, that is billions of dollars.
That is the kind of fine that wipes out a quarter's profit, tanks the stock price, and literally ends executive careers.
It forces a total paradigm shift. AI compliance is officially moving into GDPR-scale territory.
It is strict operational liability now.
If your system makes a decision that negatively impacts a citizen, say, denying them credit, rejecting their resume, or profiling them unfairly,
And you cannot provide the exact data lineage proving that the decision was compliant with the law.
you are exposed to that 7% tier.
I remember reading about the frantic Y2K bug scramble in the late 90s.
Oh, right. Everyone suddenly realizing that the underlying architecture of global computing had a fatal flaw.
And there was a hard, immovable deadline to fix it. This feels exactly like that.
It is very similar in its urgency, but the complexity here is magnitudes higher.
Right, because with Y2K, we were just trying to fix a 2-digit calendar date in legacy COBOL systems. It was basically a massive search and replace operation.
But with the AI Act, we are trying to retroactively build a legally binding cryptographic paper trail for millions of automated probabilistic black box decisions.
That is a fundamentally harder engineering problem.
And the corporate reaction to this realization is going to be highly predictable.
Very soon, like within the next 12 to 18 months, CFOs and corporate boards are going to fully wake up to the 7% exposure.
Panic will set in.
Oh, absolutely.
Yeah.
They will quietly but frantically authorize multi-million-dollar risk remediation budgets.
But here is the tragedy. If the engineering and risk leaders are not educated on the true nature of the black box, most of that capital will be entirely wasted.
The CFO will hand a massive budget to the CIO, and the CIO will just buy more proprietary vendor dashboards or put a massive SI on an even bigger retainer.
They will bleed capital into the governance trap, patching symptoms, while the structural data lineage problem remains completely unfixed.
So our mission today is to stop you, the listener, from making that exact mistake.
We need to show you how to bypass the trap and fix the foundation. And that brings us to the core actionable engine of this deep dive: execution.
We've established the terrifying stakes. Now we move from theory into absolute ground-level action.
If you're listening to this, maybe driving to work or sitting at your desk, and you're thinking, okay, I understand the risk, but how do I actually know if my specific company is exposed right now?
Here is exactly how you test it. We are going to initiate the first 24 hours of a 48-hour operational drill.
This is the crucible. This drill separates the actual operators from the theorists.
You do not need to wait for a massive consulting budget to be approved to find out if your foundation is cracked. You just need 48 hours, a mandate from leadership, and a highly targeted exercise.
The setup for day one is this. You're going to run a cross-functional mock AI incident drill.
All right, let's break this drill down into concrete steps. Step 1. You have to pick the right target.
You need to select one real, live, high-risk workflow in your enterprise.
Do not pick your internal HR chatbot that helps employees find the cafeteria menu or reset their passwords.
No. You must pick a system that has material consequences.
Credit underwriting and loan approvals. Resume screening and automated hiring filters.
Insurance claims processing. Fraud detection that literally freezes bank accounts. Algorithmic trading.
Pick a system where an AI decision directly impacts a human being's livelihood or significant corporate capital.
Okay, so you've picked the workflow. Let's say it's your automated small business loan approval system. Step 2 is the pull.
You go into whatever logs you currently have for that specific workflow, and you pull exactly 20 cases from the last quarter.
But the sources are very specific here. You do not just pull 20 random cases, you pull 20 adverse cases.
This is a critical distinction. You must pull cases where the AI system denied the loan, rejected the applicant, or flagged the account for negative action.
I really want to dig into the psychology of that for a second. Why only adverse cases? Wouldn't a truly balanced audit look at successful approvals too, just to see if the system is working smoothly?
If you are doing a performance optimization audit, yes. But we are doing a legal liability stress test.
Regulators, government auditors, and class action lawyers do not care about the thousands of times your AI got it right and everyone was happy.
They care exclusively about harm.
When the European regulator knocks on your door in 2026, they aren't going to ask to see your fastest, most successful loan approvals.
No, they are going to hand you a subpoena with a list of 20 people who filed formal complaints alleging they were unfairly discriminated against by your algorithm.
Wow. So you must test your system against the exact hostile scenario you will face in reality.
That makes complete sense. You don't test a bulletproof vest by throwing marshmallows at it. You test it with live ammunition.
Okay, so you have your 20 adverse cases, 20 angry customers who were denied loans. What is step 3?
Step 3 is the forensic reconstruction. You lock your cross-functional team in a room. You need the lead data engineer, the machine learning scientist, a compliance officer, and someone from legal.
And you challenge them to reconstruct those 20 adverse decisions perfectly.
So what does a perfect reconstruction actually entail? What data points are they looking for?
They need to prove the exact state of the universe at the millisecond that decision was made.
First, they need to find the exact raw user inputs. What exactly did the applicant type into the web form?
Second, they need the specific version of the model that was active at that precise moment.
Not just, we were using GPT-4, but which exact minor version and weight configuration was deployed in your environment at 2:14 p.m. on that Tuesday.
Third, the exact prompt hash.
Let's pause and explain that for the executives listening who might know the term hash but couldn't necessarily draw the architecture on a whiteboard, what is a prompt hash and why is it so vital?
Think of a hash as a unique digital fingerprint for a piece of text.
When your application sends a prompt to an AI model, say, analyze this financial data and determine credit risk, that text is run through a mathematical algorithm that generates a unique string of letters and numbers.
If you change even one comma in that prompt, the hash changes completely.
Storing the prompt hash proves exactly what instructions were sent to the model.
If a regulator says your prompt contained biased instructions, you can produce the hash and the corresponding text to prove exactly what was asked.
Got it. It's an immutable fingerprint of the input. So the team needs the user input, the model version, the prompt hash, the raw output from the model. Is there anything else?
Yes, and this is where most systems fail. Human touchpoints. They must track any human overrides or approvals that occurred before the final decision was delivered to the user.
Did a human agent review the AI's recommendation and click Approve Rejection? When did they do it? Based on what policy?
That brings us to step 4, the metric, the pass-fail condition for this drill.
The sources are absolutely ruthless on this point.
If your cross-functional team cannot fully reconstruct these 20 adverse decisions in under 7 calendar days without heroics, your foundation is cracked.
The risk is already existential.
That phrase, without heroics, is the most important part of the metric.
If your lead data engineer has to cancel their weekend, stay up for 3 nights straight, write custom Python scripts to scrape disparate databases, and manually match timestamps in an Excel spreadsheet to figure out what happened, you have failed the test.
The reconstruction must be a systematic, repeatable push-button process.
If it takes heroics to explain 20 cases in a mock drill, what happens when a regulator demands the logs for 200,000 decisions? The company will collapse under the forensic weight.
Let's walk the listener through what is actually going to happen when they run this drill tomorrow. Because, let's be honest, for 95% of companies, it's going to be a complete operational disaster.
Oh, absolutely. Where does the breakdown usually occur? Why is it so incredibly difficult to trace a single decision?
The breakdown happens because of profound architectural fragmentation. Let's trace our hypothetical scenario, Sarah's small business loan application.
Right. Sarah goes to your bank's website and fills out a form. That web application data, her income, her business type, is logged in a standard SQL database maintained by the IT department.
Next, the backend system triggers an API call to a large language model hosted by a third-party cloud provider to assess her business plan.
The cloud provider logs the prompt you sent and the response the model generated, but they log it in their own proprietary format in a completely different cloud environment, entirely disconnected from your SQL database.
Okay, so already we have the input in System A and the AI processing in System B.
Exactly. Now, let's say the LLM analyzes her business plan and outputs a risk score of 85 out of 100, flagging it as high risk.
Your internal routing software sees that high score and sends Sarah's file to a human underwriter for review.
The human underwriter opens the file in a completely separate case management tool, maybe Jira or ServiceNow or Salesforce.
The human looks at it, agrees with the AI's high-risk assessment, and clicks Reject. Sarah gets an email saying she was denied.
So you have the user input in the SQL database, the AI logic trapped in the cloud vendor's logs, and the human override recorded in Salesforce.
And here is the fatal flaw. None of these systems share a unified identifier, a continuous timestamp, or a data lineage graph.
So when the legal department knocks on the door and says, Sarah is suing us for discriminatory lending, prove exactly why we denied her, the engineering team descends into chaos.
They have to pull Sarah's SQL record. Then they have to guess the approximate timestamp and comb through millions of lines of the cloud provider's API logs to find the prompt that might be hers.
They might discover the API log didn't capture the exact version of the model weights active at that moment.
Finally, they have to try and cross-reference that with a Salesforce ticket that the human underwriter might have closed 3 days later.
It's like trying to solve a complex crime where the key witnesses all speak different languages, live in different countries, and absolutely refuse to talk to each other.
And you are the detective trying to piece together a timeline using incomplete train tickets.
It is a forensic impossibility.
And documenting every single missing artifact during this drill. Every missing timestamp, every untracked prompt hash, every disconnected human override, that is exactly what you want.
You want the system to break. You want to expose the catastrophic gaps now in a controlled mock drill, rather than discovering them in front of a European regulator in 2026.
Because the pain and panic of day one is the exact fuel you need for day two.
You cannot walk into the CFO's office and ask for a multi-million-dollar infrastructure budget based on a theoretical white paper about AI ethics.
They will laugh you right out of the room.
You have to show them the exact mathematical points where the bridge is currently collapsing under their feet.
Which brings us to the crucial pivot. Execution day two, mapping the findings and drafting the board memo.
Day one exposed the terrifying gaps. Day two is about translating that localized panic among the engineers into a strategic, undeniable mandate from the board.
This requires a massive shift in communication style. You are moving away from engineering forensics and stepping straight into the realm of executive risk strategy.
Step one of day two is the synthesis. You take the messy, chaotic list of missing artifacts in the day one drill. The untraceable hashes, the disconnected Salesforce tickets, the blind spots in the API gateway.
And you synthesize them into a strict 2-page board note.
2 pages. Not a 50-page slide deck with elaborate animations.
Absolutely not. 2 pages of dense, highly legible operational reality. Executives do not have time for fluff.
So what exactly goes into those 2 pages? Because you can't just list technical jargon. If you tell the CFO, we are dropping prompt hashes at the API gateway, their eyes are going to glaze over.
You have to map the technical audit findings directly to the legal compliance obligations.
Precisely. You must speak the native language of the general counsel and the chief financial officer. Risk and capital.
You take a technical finding, for example. We cannot reliably prove which version of the LLM processed Sarah's credit application on Tuesday.
And you map that directly to the text of the EU AI Act.
You're right. Finding 1. Inability to trace model versioning. This missing data lineage directly violates Article 12 of the EU AI Act regarding continuous logging and traceability for high-risk systems. This specific failure exposes the firm to maximum penalty tiers.
You draw a straight, undeniable line between the missing log file and the broken law.
Yeah.
Then comes the most powerful part of the memo, the financial equation.
You create a stark side-by-side comparison of asymmetry. On the left side of the page, you outline the rough estimated cost of building or buying a unified AI evidence stack.
Let's say for a massive enterprise deployment, it's a $3 million capital expenditure.
On the right side of the page, you put the potential capital exposure. You calculate 7% of your company's global turnover.
If your company makes $5 billion a year, that exposure is $350 million.
When you present that mathematical asymmetry to a chief financial officer, the tenor of the conversation changes instantly.
CFOs are masters of understanding asymmetric risk.
If you go to the CFO and ask for $3 million for a cutting-edge AI governance tool, you will be put in a queue, scrutinized, and probably denied.
But if you present a memo that effectively says, based on a live audit we conducted yesterday, we have a mathematically proven documentable exposure of $350 million because we cannot pass a basic regulatory inquiry. However, we can mitigate that risk entirely with a $3 million infrastructure investment.
The budget unlocks. It's basically a no-brainer.
You aren't going to the CFO asking for a new toy for the engineering team.
You are handing them a heavy-duty fire extinguisher, while calmly pointing out that the building they are standing in is currently constructed of dry wood and soaked in gasoline.
That is the exact mindset. And the memo must end with a highly specific ask.
You do not ask for permission to rip out all existing legacy systems and build a massive global architecture overnight. That is way too much friction.
You use the terrifying reality of the memo to secure a mandate to pilot an evidence stack on one single workflow, the exact workflow you just audited.
You say, give us the mandate and the budget to build the control point on the small business loan system. Let us prove we can make it bulletproof. Once we prove it works, we scale it across the enterprise.
We really need to touch on the tone of this memo because our sources were absolutely adamant about the voice.
It must sound like an operator who has actually built things that matter.
It needs to be precise, grounded entirely in reality, highlighting operational loopholes, and completely devoid of marketing hype.
No buzzwords, no talk of synergy or next-gen AI revolution. Just cold, hard operational truth.
The tone should project quiet, authoritative confidence. The memo must subtly position this new evidence stack, not as a niche IT project, but as foundational shared infrastructure.
It is the necessary connective tissue between the general counsel who needs legal cover, the chief risk officer who needs to quantify exposure, the chief data officer who needs lineage, and the CIO who needs system stability.
The subtext of the 2 pages should communicate. This evidence stack is the one piece of infrastructure everyone in the C-suite needs to ensure they keep their jobs after our first major AI incident.
I love that. It aligns everyone's deepest personal incentives toward corporate survival.
Okay, let's play this out. The CFO reads the memo. They see the 7% exposure. They see the failed 48-hour drill.
They do the math, they sign the check, and they approve the pilot. Now what? What are we actually building?
That brings us to architecting the solution. What does this digital flight data recorder actually look like under the hood?
We need to define both the deep technical capabilities and the fascinating philosophical architecture of this control point.
This is where we get into the structural engineering of the black box. Let's start with the technical engine. A true evidence stack consists of 5 non-negotiable core pillars.
Let's walk through them. ELI 5 style. Pillar 1, data capture.
Data capture is about intercepting the flow of information without slowing down the application. You cannot rely on developers to manually remember to log things.
You need automated connectors, API gateways that plug directly into the data stream.
Imagine the gateway as a toll booth on the highway between your user and the AI model. Every piece of data must pass through it.
It intercepts the exact user payload, stamps it with an atomic timestamp, and captures the user context the exact millisecond before it hits the model.
And it captures the model's response the millisecond it comes back. It does this passively, immutably, and instantly.
Okay, the toll booth has captured the data. Pillar 2, storage and lineage.
Once captured, that data cannot just be dumped into a standard SQL database where a rogue developer or a panic administrator could accidentally or intentionally delete a row to cover up a mistake.
It requires tamper evidence storage. This is where cryptographic hashing comes in.
When a log is recorded, it is mathematically hashed and linked to the log before it, creating a chain.
If someone tries to alter a log from Tuesday, it breaks the mathematical chain for Wednesday and Thursday, immediately flagging the tampering.
Alongside this secure storage, the system builds lineage graphs. It automatically draws the lines connecting Sarah's user input, the exact model weights used, the prompt hash, and the human underwriter's JIRA ticket, creating an unbreakable visual chain of evidence.
Pillar 3 is the policy engine, and I really want to drill into this based on our sources because this is where the magic happens.
We are talking about turning legal requirements into executable code, right? Not just PDF manuals sitting on a corporate intranet.
Exactly. A PDF policy document is utterly useless to an automated system processing 10,000 decisions a second.
The evidence stack must be able to ingest human legal requirements like fairness thresholds or risk classifications and turn them into computational rules.
If the EU AI Act says a certain type of demographic profiling is strictly prohibited for loan applications, the policy engine hardcodes that prohibition into the gateway.
If a rogue model hallucination tries to output a decision that violates that mathematical threshold, the evidence stack physically blocks the output from reaching the user, flags it, and alerts the risk team.
It enforces the law at the code level.
Pillar 4.
Workflow.
This is the interface where the humans interact with the evidence. It provides case management for incident response.
When the European regulator demands the audit of those 20 adverse cases, this is the module where your compliance officer logs in, types in the case IDs, clicks a button, and generates a mathematically proven, legally sound lineage report in 3 minutes, rather than 7 days.
And finally, Pillar 5. Change control. Binding model updates and policy updates together.
Yes. You cannot have a siloed data science team updating a model's foundational weights on a Friday afternoon without the compliance team simultaneously updating the associated risk policy.
The evidence stack binds those approvals together at the system level.
A new model deployment is physically blocked by the system until the corresponding policy update is digitally signed off by legal within the same interface.
Okay, so that is the heavy technical architecture. But our sources provided something incredibly unique and unexpected here. They didn't just give us API specs. They gave us a highly specific, deeply philosophical visual directive for how this software interface should actually look to the user.
They reference Dieter Rams. For those who don't know, Dieter Rams is the legendary industrial designer behind the golden age of Braun electronics and a massive inspiration for early Apple products.
His philosophy is all about engineered minimalism, restraint, less but better.
Yes, the visual architecture discussion in the sources is profound. They explicitly state that the user interface of this evidence stack should not look like a cliched Hollywood hacking movie.
It should not have glowing blue cyber lines, dark web aesthetics, or floating holographic nodes.
It must embody absolute functional clarity. It must look visually like critical safety infrastructure.
They described it like a physical control unit.
Yeah.
Imagine an aviation instrument panel translated into software.
Matte black elements, the visual texture of satin finishes and anodized aluminum, e-ink style displays.
The UI background should be a stark, light gray with dark gray text, perfectly aligned to a rigorous typographic grid.
And it should use color with extreme restraint. Perhaps a single, highly deliberate functional accent color, like a muted brawn orange or a precise indicator green, used only to highlight a compliance flag.
It uses the visual language of high-end mechanical engineering and analog instrumentation.
I have to play devil's advocate here because I can hear the IT buyers rolling their eyes.
We are talking about B2B enterprise compliance software. Why does the look of it matter so much?
Why are we spending time talking about the visual texture of anodized aluminum and mechanical precision for a piece of code? Does the UI really change the legal standing of the cryptographic hash?
It doesn't change the underlying math of the hash, no. But the interface design fundamentally dictates the emotional tone, the trust, and the operational behavior of the user.
Think back to our first story, the factory workers handling the grenades.
The interface to the evidence stack must project the emotional tone of quiet confidence and undeniable accountability.
It must project the absolute, immutable authority of a physical flight data recorder.
When a chief risk officer, or an external auditor, or a government regulator looks at this screen, they should not feel like they're looking at a flimsy marketing dashboard built in a weekend.
They should feel the weight of a rigorously engineered system. The interface reassures the human operator that they are protected from systemic risk.
It is the visual manifestation of order out of chaos. If the UI looks fragile or chaotic, the human trust in the underlying data instantly evaporates.
Wow. The visual manifestation of order out of chaos. That makes perfect sense.
You want the system to feel as solid, heavy, and immutable as the cryptographic data it holds.
You want the regulator to look at the screen and instantly, subconsciously know these people are operating with rigorous, mature control.
Which brings us to our final major realization. And honestly, this is the most exciting part of this entire deep dive.
The ultimate flip, turning the evidence stack into a sales asset.
We've audited the broken system, we've survived the panic of day one, we've secured the CFO's budget on day two, and we've architected this beautiful, Dieter Rams-inspired stack of immutable truth.
Now what?
Now, you realize that this entire grueling exercise wasn't just about playing defense.
It wasn't just a cost center project to avoid a 7% fine.
It is about making money. It is about capturing a massive structural strategic advantage in the marketplace.
Let's explain this concept of competitive asymmetry.
Competitive asymmetry occurs when one player in a market possesses a foundational operational capability that their competitors lack, and that capability suddenly becomes the most highly valued currency by the buyers in that market.
Right now, as you were building this evidence stack, your competitors are still bleeding capital into systems integrator.
Your competitors are still arguing about abstract AI ethics in PowerPoint presentations.
If a major enterprise client asks your competitor about AI safety, your competitor hands them a generic 40-page white paper provided by their cloud vendor.
But you have the evidence stack. You have a single engineered minimalist interface where any AI decision your company makes can be forensically reconstructed and definitively linked to legal policy in a matter of minutes.
Exactly. So picture the scenario. You are sitting down for a massive multi-million-dollar enterprise client negotiation. You are trying to sell them your AI-powered software suite.
The client's procurement team is nervous. Their legal team is pushing back hard.
They look across the table and ask, how do we know your AI won't hallucinate and expose our company to massive liability?
You do not just give them a verbal promise. You do not hand them a glossy brochure.
You open your laptop, you bring up the evidence stack interface, and you show them the lineage graph.
You run a live, real-time query showing exactly how a complex AI decision is traced backward, millisecond by millisecond, to human consent and regulatory policy.
It's the ultimate flex. It's like walking into a restaurant, right?
Right.
You ask the manager if the kitchen is clean.
And instead of showing you the kitchen, the manager hands you a PDF pamphlet about their cleanliness synergy strategy.
Right. Meanwhile, the chef at the restaurant next door doesn't say a word. They just point through an open glass window to a spotless, gleaming, stainless steel kitchen where you can watch every single meal being prepped.
Who are you buying dinner from?
You buy from the chef who shows you the operation.
Trust is the ultimate bottleneck in enterprise AI adoption right now. Every buyer is terrified of liability.
When you can visually and cryptographically prove your data lineage, you negotiate from a position of absolute strength.
You operate with the quiet confidence of an organization that knows its foundation is secure.
This flips a terrifying regulatory nightmare into a highly distinct, highly visible sales asset. The compliance tool becomes a massive revenue driver.
And as our sources reminded us at the very beginning with the grenade story, real technology doesn't exist just to generate hype.
It exists to reduce risk, restore the human, and make meaningful work safer.
Owning this operational choke point, the unified evidence layer, is the ultimate leverage in the market leading up to 2026.
It is the defining line between a company that treats AI as a novelty and a company that treats AI as industrial-grade, mission-critical infrastructure.
Let's bring this all together. What an incredible journey this has been. Let's synthesize the roadmap for you.
We started by confronting the terrifying reality of the missing black box, that agonizing scramble when legal asks, why did the AI do this? And you realize you have no idea.
We mapped out the governance trap, exposing how cloud vendors and consulting firms actively benefit from keeping your data lineage fragmented and obscure.
We stared down the barrel of the 2026 cliff with the EU AI Act threatening fines of 7% of global turnover, shifting AI from an ethics debate to a massive balance sheet liability.
And then we moved to concrete action. We outlined the brutal but necessary 48-hour drill, pulling 20 adverse cases to expose the forensic nightmare of your current architecture.
We showed you how to draft the 2-page board memo to secure the CFO's budget, pitting the cost of the infrastructure against the brutal math of that 7% fine.
We architected the system itself, from API gateways to cryptographic hashes to policy as code, grounded in the visual principles of Dieter Rams's engineered minimalism, creating a tool that projects quiet, unshakable authority.
And finally, we showed you how to take that defensive infrastructure and turn it into the ultimate offensive weapon in a client negotiation, using competitive asymmetry to drive revenue.
So as we wrap up this deep dive, I want to leave you with a final provocative thought, drawn directly from the ethos of the operators who wrote our source material.
Consider this carefully. The question is no longer whether a critical AI incident will occur in your business. With the sheer volume of probabilistic, automated decisions happening every second, a high-profile incident is a mathematical certainty.
The only question that matters is whether you have the quiet, unglamorous, deeply engineered architecture built to explain it when it happens.
Are you building technology just for the headlines, for the fleeting applause of a tech blog? Or are you building the deep, rigorous infrastructure that lets your team, your clients, and your board go home at the end of the day and say, we are safe today?
Yeah.
The clock is ticking toward 2026. Start your 48-hour drill tomorrow morning.